This is video 4, chapter 4, section 3, right triangle trigonometry. Okay, I know you're familiar with right triangles. I'm going to ask you to look at this right triangle that I have over on the left side of the screen. Let's just talk about the parts of the triangle. You know, in a right triangle there are two legs, and then there is a longest side, which is called the hypotenuse. Now, if you look at this particular triangle that I have here, I have an angle marked theta. Theta is one of the two acute angles in the triangle. And if you remember your definitions from the trig functions that you perhaps learned in 10th grade, if you come straight across from theta, you will have a side which we refer to as the opposite side of theta. And then when you have your hypotenuse, you have one side left over, and for lack of a better term, we'll call it the adjacent side. Adjacent means next to, and there are actually two sides next to angle theta, but one's already labeled the hypotenuse. So we will call 5 the opposite side, 8 the adjacent side, and theta, this side over here, the hypotenuse. So I'm just going to abbreviate these OA and H. Now, as you change angles, as you move your angle around the triangle, your sides can change. Your O and your A can change places. Your hypotenuse is always fixed. Now, on the left side of the screen, you see the 6 trigonometric functions that we've been talking about in class. We've been talking about today the X, Y, R definitions, which are new. Let's go back and review the OAH definitions. Sine equals O over H. Cosine equals A over H, and tangent equals O over A. That's Oscar had a hunk of apple, or however you choose to remember it. Now, given the relationships that we've talked about in class, you remember that these two functions are reciprocals. So we can say that the cotangent then is A over O, and the secant is the opposite of the cosine. So it could be H over A, and the sine reverses to become the cosecant, and the cosecant is H over O. So this is just like what we've been doing with the X, Y, and R definitions, only these are O, A, H, which are only useful for right triangles. So in this particular case, if we wanted to find the values of angle theta right here, your opposite is 5, your adjacent is 8, and you don't have a value for your hypotenuse. I'm going to write this again right here since I've written all over that and it may be a little hard to see. This is your right angle. This is your angle theta. This is a 5, and this is an 8. The first order of business is to find the length of the hypotenuse. This is your Pythagorean theorem. 8 squared plus 5 squared equals c squared. That's 64 plus 25 equals c squared. That's 89 equals c squared. And c is equal to the square root of 89, which will not simplify. So there we have it. All right, again, based on this angle, this is your opposite side. This is your hypotenuse. This is your adjacent side. So let's go find the values for these trig functions. The sine is 5 over the square root of 89. And I'm going to leave that for now. I'll go back and simplify it in a minute. Your cosine is 8 over the square root of 89. Your tangent is 5 over 8. Your cotangent is 8 over 5. Your secant is the square root of 89 over 8. And your cosecant is the square root of 89 over 5. Now, once you've finished and you've got everything flipped, you can go back and simplify this one, get that radical out of the denominator. Same way with this one, 8 radical 89 over 89, and you're done. Remember, right triangles are governed by the Pythagorean theorem, so if you have two sides, you can always find the third, and then you're in business. Now let's talk about some applications of right triangle trig. By the way, this is the trig that you were introduced to in 10th grade, so you have seen this before if you're thinking it looks familiar. Okay, now remember that with these triangles, you have a set of word problems related to angles of elevation and depression. And you might remember that here is a point on the ground. We'll make it be a little bug. And here is a bird flying. You should be an art teacher. Woo! Okay, a bird flying up in the sky. Now, if the bird and the bug are looking at each other, for whatever reason, the line that connects them is called the line of sight. Now, the bug is on the ground and the bird is in the sky. And you have two angles that are formed here. You have the angle that is formed between the bug and the ground, right here, which I'll call theta. And you have the angle that is formed here, which I'll call alpha. Now, one thing you should realize is these two angles are alternate interior angles because these lines are parallel and they are congruent. This is called the angle of elevation. And this one is called the angle of depression. And they are the same. And that's important to know because when you're drawing a triangle and working one of these problems, you need to know that the angle of elevation will always be at the ground. The angle of depression will always be up in the air. Usually the angle of depression is not in your triangle. So if it talks about the angle of depression, you can just kind of scratch through that and call it the angle of elevation and move right on down. Let me show you an example of one of these problems and then we're going to work some in class. A flagpole casts a shadow of 75 feet. If the angle of elevation of the sun is 32.5 degrees, how tall is the flagpole? Now your first step is to go ahead and draw a right triangle. We're going to assume this flagpole is parallel to the ground, is completely perpendicular to the ground. So let's just draw it something like that. Now, the shadow is on the ground, so let's draw that 75 feet. We want to know how tall is the flagpole, so we'll put an X over there. And the angle of the elevation of the sun is located right here. You remember I told you the angle of elevation is always at the ground. So 32.5 degrees. Now, we look at this and we think about our O and our A and our H as they relate to this figure. Our angle is here, so this is the O and this is the A. If the A is giving you problems, remember it's the one that's not the O and not the H. It's the one that's left over. Now, we need a function that uses what we know, A, and what we need, O and A. And usually you'll choose from one of the big three, sine, cosine, or tangent. So we want to use the tangent function. Tangent is O over A. So we will say that the tangent of 32.5 is equal to O over A, X over 75. Now, this is why we make sure that our calculators are set to degrees. We will go find our calculator. We're going to push the button that's marked trig. And when we are on the trig function, we will scroll over to tangent. We'll punch that in and ask our calculator for the tangent of 32.5. Now we will get a bunch of digits, so we're going to round it to 4 decimal places, and you will find that that is 0.6371 is equal to X over 75. And we will multiply that, we'll cross multiply in fact, and our answer is about 47.78, and I'll give you some rounding instructions. So let's just say X is approximately 47.78, and the unit will be the same as the shadow, which was feet. So our answer is 47.78 feet. Now you can work all kinds of angles of elevation and depression problems. I'll be showing you some more complicated problems in class, but this is enough to get you an introduction. Let me show you just one quick problem that involves multiple triangles. Let's say there is a lighthouse, and let's just say, for lack of a better drawing, the lighthouse looks kind of like this. And let's say it's sitting on a point of land, and it looks out to one side and it spots a little boat over here, and the angle of depression to the boat is 46.3 degrees angle of depression. Okay, and out the other side, it spots another boat on the other side of the lighthouse, and the angle of depression to it is 72.4 degrees. Also an angle of depression. And the question is, how far apart are the ships? And you need one more piece of the puzzle, and that is that the lighthouse is 39 feet tall. Okay? So imagine now we take this drawing and we convert it into right triangles. So we're going to come down here, straight down the lighthouse. We're going to come straight out here to the ship, and we're going to finish this triangle like this. There's triangle number one. And then we're going to do the same thing to this, from the same point to this ship, and we'll assume, I didn't hit it very well, but let's assume these are both in line and these are both right angles. All right, so here's our picture. Now both of these triangles mention an angle of depression. Now keep in mind, the angle of depression is actually out here in the sky. So let's just flip that over, and instead of talking about an angle of depression, let's call that the angle of elevation, which is always between the ground and the line of sight, 46.3 degrees. And same thing over here, cross out depression, change it to an angle of elevation, 72.4 degrees. Now, what we want to know is we want to know how long this is, we'll call it X, and we want to know how this long that is, we'll call it Y. It's two separate problems. And then when we finish, we will add the two together. So right up here, I'm going to make a little sketch of this situation, which is, we've got a 39-foot lighthouse. We got a 72.4 degree angle, and we want to know what this is. So the tangent of 72.4 is equal to 39 over x, because this is the opposite and this is the adjacent. Now you might be wondering why I'm using tangent in all these examples. Tangent is often used because it is easier to measure a vertical or a horizontal distance than it is to measure through the sky, this diagonal distance. So you'll see a lot of tangent problems. Now, you'll notice on this one, the x is down in the denominator. Let me offer you a suggestion. This is just a technique for solution. You can switch diagonally these two elements. So you could basically change this equation to x equals 39 divided by the tan of 72.4. We call that diagonal switch. And it allows you to work the problem without having to, worry too much about your division. You're just going to switch the x and any element that's diagonal. So the solution is going to be found by dividing 39 by the tangent. Again, use your trig button and toggle over to tan by the tan of 72.4. And that answer is 12.37 feet. I'm going to write that on here, 12.37 feet. Then switch to the other side. Do the same thing. I'm about to run out of time here, so I'm just going to write quickly. This is 46.3 this is 39, and you want to solve for